Hello, welcome back to Multi Skills College. Today, Brian the electrician is going to teach us how to install a one-way lighting circuit and also test it.
First thing we need to do is fix the consumer unit. As this is a timber, we use a bradawl. We make a small hole into wood with a bradawl. These are very fiddly. Steady it with your finger and then tighten it in. Just check the others, which we've done earlier. You can always work out where the top is because there's always one in the center. Right, this is a switch batteries. This device here is called a pack gland. This is a batteries we're going to use for the switch, and I'm going to show you how to take this out. Depending on the manufacturer, these can be very difficult. Sometimes you have to drill them, sometimes they will tap out. If they would tap out, I'd recommend using an old screwdriver and turn the hammer on the side and give it a tap. This is a gland we need to use so the cable can go in, and the name of this gland is a pack gland. It has got a nickname, but we won't use that. So we just insert that in. You want to line this edge up with the flat of the box. Otherwise you'd have trouble getting this in. And you just turn that in gently until it starts to grip. Do it up finger tight, and then you can get an adjustable there to do it up tight. You won't need to put anything on this nut because the flat would hold tight on there. So you just need to pinch this up so it's tight. If you do too tight, then this gasket will start to spill out. Just back this off. Do not take it right off because there is a sealed grommet in there. You poke your cable through to about 150 mil. This will be clipped down like this, and then you would tighten this up. You do it up hand tight, and then to tighten it up, you would do it up tighter with a pair of adjustables. And you check this is in tight. You can see you can't pull it out. And an ideal thing is to line up the flats so it looks neat. And then we've got already one fixing in here, so we need to make another fixing here using the bradawl exactly as we done on the consumer unit. Right, in line with the switch is the back batteries plate, and you notice we have two fixings in. Use the same type of screws. This device is called a pendant. They come in various sizes, but you can change them to what length you want. So we need to screw this on. But when you put this on, to make sure that you can get access to the terminals easy, we're going to be using M4 screws to screw this back. Next, we're going to put our cable in. This is 1mm twin and a half for lighting. So we're just going to push this into our switch. Leave it approximately about 150, and we're going to clip this into position. These are 1mm clips to hold the cable in position. So we're going to cut this off around about 100 to 150 inside here, and we can cut the cable back accordingly. Now we need to wire from the ceiling rose to our consumer unit. Keep it the same length. Dress this cable round. And you need to get a nice bend, radius bend on this. Then we can clip the cable in position. Same again, we're going to clip this cable along. It's important you notice that the nail follows the way around, so the nail supports the cable. So if you do this bit first, make sure you understand which way the nail is going to go. It's got a nice sleeping bend on it. Need one more clip, I think, by the look of it. Now all the cables in, we need to strip the cables back and terminate. The easiest way to strip this is to cut down the middle with a pair of side cutters and pull back. If it's cold, this will be hard at the strip. This white powder inside is French chalk. Same on this one. Takes a bit of pulling sometimes. Be careful when you cut this off. Now we do the same this end, cut down the middle and pull back. This one we show you a slightly different method. You can take the CPC, circuit protective conductor, and put it back. Right, now we've got all the cables stripped, we need to terminate. So we're going to start at the consumer unit, up to the lighting point, then down to the switch. This is a two-way consumer unit. So this is circuit number 1, circuit number 2, circuit number 1, circuit number 2, and on the earth bar, circuit number 1, circuit number 2. So we do not cut these cables short, we just dress them accordingly. So we can push this one underneath on this particular board. And we're going to terminate that one in there. We need to double this over so the screw does not bite through the cable. That's one method, and then the next one I will show you a different method. Right, so we're going to loosen this terminal off. We're going to terminate this conductor into here. If you notice, it's doubled over. So we put this in here, the insulation goes right the way up to the terminal. When we terminate a conductor, we always do a little pull test to make sure it's okay. Same with our line conductor. That's going to come here, but we keep these the same length. What you do, you dress it down the back so you don't alter the length of the cable. So that needs to go into there. This time we're going to use the wire strippers. You have to adjust these accordingly. Now we can trim this to fit, double this over. You can use your finger to guess about 50% where you want to double it over, like that. So you can hold that there, so this will double over. We've got two screws here. The newer ones have only got one screw terminal. This is an earlier one. So we're going to adjust that in there. Again, do this up. Again, we're just going to adjust that into position. So this is our CPC, which we need to put some yellow and green sleeving on. So we can measure this approximately to the length, cut it off accordingly. And we've got enough here for doing our termination. We've got to get this down to there so we can dress it round the back. You may have to push this back over. And it's going to go into this terminal here. Hold it in position and do the screw up. And again, we want to do a little pull test, make sure it doesn't come out. So we've terminated all our three conductors. We can dress that around accordingly, just to tidy it up. And that's that end completed. Right, so we have a brown and a blue CPC, a brown CPC, sorry, a brown CPC and blue. It's best first to connect the CPCs, circuit protective inductor, so they're out of the way. It's important, but both of these come in from the same side. So this is very short pieces of CPC sleeving. You can use a pair of side cutters for this. Cut them roughly the same length. Place the CPC sleeving over. You do not twist these. Because this screw terminal is quite large, what we're going to do is dress these round and put these in together like that. So you can see where they've got to go. So we can cut these. When you cut these, be very careful the bits flying off, because a visit to the hospital is not very nice. Again, do a little pull test. And we can just see they're going quite nicely. You have two blues here, but one of them is a switch line. The one from the consumer unit coming around here, which is this one, goes to the blue for the lamp. So again, we can dress this in position. So you can use, if you wish, a pair of side cutters to strip this, a pair of pliers, or the actual wire strippers. Now, because these are single terminations, they should always be bent over. This is the one which is going to go in. So undo that screw. Be careful not to take it fully out, because you'd have trouble putting it back in. Again, little pull test. Just dress that in position, out the way. What we should do while we're here, just check these are done up tight. As you can see, they're not quite tight. Loose connections cause fires. Now we're going to put the two browns into the center terminals here. So we dress them accordingly, about there. Again, we're going to cut those off. And again, we're going to strip these. Again, we need to bend these over. It's important when we bend them over, the bend over bit goes right up to the insulation and there's no gap there. Now these are ready to terminate. So we're going to go into this terminal and this one. Little pull test. If you get in the habit when you terminate to do a little pull test, then you haven't got to go back when you're sorting out other problems. That's those two terminated. Now this one that comes up from the switch is the switch line. Right. Because this conductor is not a neutral, it is the switch line, so we have to indicate the switch line with some brown sleeving. To indicate this conductor becomes live. If you was to leave it like that, you'd have problems in terminating it. So you must crimp it up with the pliers. You can see the difference. Some people might use brown tape, but unfortunately the tape can come off. Sleeving is the correct way of terminating it. Now we're going to terminate into this conductor, into this terminal. If the screw's not open fully, as you can see, it won't go in. So you have to undo it, wiggle it, and it will go in. Again, do a little pull test. Now we've got all the conductors connected correctly. Now we're terminating the switch. So the most important conductor in any circuit is the circuit protective conductor. You may know it as the earth wire, because that's the one what will save your life. So we're going to adjust the sleeving accordingly. This is a genuine Wago connection. There are other makes, but these are the best. Now this particular type are reusable. It's because they have these little levers. You just move the lever up, as so, and we push our CPC into that connection. And you can see it doesn't come out. To take it out, it's the reverse action. Move the lever up and pull it off. Now we can assemble that out of the way of the switch. So we just put it up that way up so you can see it. Right, if you need to take this off, you can't pull it out. You have to lift up the little Wago lever. Best to use your fingers because you can break them. And then we can take it out. So put back in, it's the reverse, hold it in position and click it down. And you can see it doesn't come out. You may find some boxes have an earth terminal in there. If they can, you can use that. If it hasn't, then you've got to put your own. But this has to have a piece of brown sleeving to indicate it becomes live. So again, we're going to double this over. So we've stripped this, doubled this over. We do the same on this conductor. Then we've got to put a piece of brown sleeving over this to indicate it becomes live. So we have to indicate this conductor becomes live with brown sleeving. Regulations state it has to be a piece of brown sleeving, but certain organisations request 75% of the conductor length. Save measuring the whole, so what 75% is, most people just measure it 100%. Now we need to terminate the switch. We need to check the switch, what type it is, and have a look at the connections. So there should be a terminal marked common. Sometimes these are marked L1 or L2. This particular switch, if we look, it's got no connection there, no connection there, only two connections there. So there's only one way it can be connected. The brown, this brown, always goes in the common. This brown goes into the common, which is the live, and this is the switch line that goes into this terminal. Pull test, and then this one's got to go in there, so you undo the screw. Just give this a little pull through a little bit. So now we know it's all terminated. Next test we have to do is to check it's functioning correctly. Now it's completely wired, we have to go through this sequence of testing laid down here. This is our basic tester we're going to use. This does insulation and continuity. Before we can use this tester, we have to check that it is functioning and there's no mechanical damage, otherwise it could affect the readings. So we just have a visual inspection, there's no mechanical damage on here, and the leads are clearly marked where they go. These are our leads. We quickly need to check these. There's no damage on the leads. Then we can plug these in to the correct terminals. And we switch this on to the ohm sign to do the continuity. This takes a little bit of time for the software to settle down. And we're going to short the leads together to see what reading we get. And we get 0, 0, 0. So therefore we know the resistance of the leads is 0. We need to check the CPC of the circuit. So we need to go to the consumer unit. So we need to click this crocodile clip onto the earth bar, and the other one to the furthest point, which is this one. As we use the Wago, we can quickly disconnect that. We connected one to the earth bar at the consumer unit. This is the furthest point because the CPC is connected here. So we're going to connect this in. Just make sure that's a good connection. And we got 0.02. If the reading is greater than 0.05, it's possibly you have a loose connection, or the battery on your instrument is low. Next test we're going to do is insulation resistance, and we test at twice nominal voltage, which is 500 volts. We check our meter is working by shorting the leads together, and we should get a 0 when we hit the test button, which we do. Leads apart, and we should get a very high reading. That's check the function of the meter is functioning correctly. Now we need to do our insulation resistance. Before we can do that, we need to remove the lamp. We've got to go between line and neutral, line and earth, and neutral and earth. Earth is known as CPC, circuit protective conducting. So we can go back to our consumer unit. So the first test is line to neutral. So we know neutral is there. So we can connect that on. And we know our live is there. Make sure this is in the off position. And then we're going to do that test. And we should get a very high reading. Greater than 1000 megohms. If we was to leave the lamp in, and we operate the switch, you'll see you'll get a 0 reading, indicating there's something wrong. If you get a low reading, we simulate a low reading. between line and neutral. If the lamp's not in circuit, then it's possibly the cable has been damaged by a nail or something, or a rodent, or acid attack. To E, so we can leave this one connected and go straight over to the earth terminal. Make sure the switch is on and the lamp is out of circuit, and again it should be a very high reading. There it is, 1000 megohms. Okay, when testing the insulation resistance, you have to make sure all switches are on and all lamps are out of circuit. The last test we're going to do on insulation is neutral earth. So therefore we can leave this connected to the earth terminal, move this one to the neutral terminal. And again, we're going to do the test. It says greater than 1000 megohms. So we can write that value in. The minimum insulation resistance value for testing is 1 megohm. So we've got 1000 megohms, so therefore the insulation is perfectly safe. Polarity test we can do quite simply is by this instrument has a what's called a buzzer range on it. So we can switch this round to the buzzer, and when the leads are shorted together, it makes a noise. So we need to check the polarity. So we're going to check from the line conductor here right up to the lighting point. This time we have to use a probe. So we're going to go up to where the lamp is switched on. If you operate the switch, that's the switch in the off position, switch in the on position, and you can see it makes a sound. It means the line conductor is correct and the polarity of that conductor is correct. If we check the CPC, there's possibly the neutral is correct, but it doesn't take long to check. So we're just going to clip onto the neutral bar, and we go up to the neutral on the lighting point, and again we should get the same sort of reading. This time the switch won't make no difference because the neutral is a direct connection. Make is Mega, and this is a MIT 300. Now the serial number may be a bit tricky on this particular instrument, is because the serial number is inside. You have to clip this cover off, and this is where the serial number is. We obtain the serial number, put there just your signature and date. The reading we got on the meter was 1000 megohms. This sign here, a V on the side with a line underneath, means it's greater than 1000 megohms. Now we've completed all the electrical testing, we need to secure the covers, and then we can energize the circuit. Both off, put the main supply on, put the breaker on, the switch is down so we know the light's on, and that's off, so it's functioning correctly.
Now you know how to install and test a one-way lighting circuit, it's your turn to have a go.